Hi, my name is Kunal Raj. In this video, I'm going to demonstrate Unix and Linux lab exercise number 10. Title of the experiment is Interprocess Communication using shared memory. So, the process one will create a shared memory and write some string into the shared memory, then waits for the other process to read and modify it, and then process 2 will get the shared memory and will modify it. So, in the modification part, the process will read the string and reverse it, and then it will modify into the shared memory part. So now, first of all, let us see the compilation part. So here, in one terminal, I'll execute process A. So here I'll execute process A, and then I'll compile it, and then asking for key. So I'll enter some random key number, and it'll give the process will be created here, and then I'll enter some key here, some string here. Now it will wait. So I'll go to next terminal, and then I will give process B here, and it will ask for the key. I'll enter the same key. So here the reverse of the string is the string is reversed here, and it will be modified into the shared memory, and the effect, as you can see, will be shown here. So using the same shared memory, the reverse of the string is happened. Now let us see the code for both program. So for the first one, here the header files that are included are sys.shm.h and then sys.ipc.h for interprocess communication. Now it's asking to enter the key for shared memory, so I'll enter the key. Then using system call called shmget, you can create the shared memory. You have to pass the value of key, then size value, then you have to pass the permission, that is 0764 and ipc underscore create. Then just print the ID that has been returned. I am printing here. If the ID is less than 0, that means the shared memory is not created. Otherwise, you have to create a character pointer to point to the shared memory. So you can so this is the typecasting. So the return value will not be character pointer, so we'll start typecast here. Then using another system called shm at, and it will point to the shared memory where the shared memory is. So the pointer will point to that shared memory, and then we'll pass the value here. Now using string pointer, it will just copy the address to the string. So wherever virtual address this variable is pointing, this variable will also point to the same pointer. Now enter the string. It will enter the string. It will wait for 15 seconds so that process B will be executed, and then the modified string will be printed. Now let us see the process B. So process B will receive the string and it will reverse it. So here I'm having a user defined reverse function for reversing the string, which will accept character string, and it will reverse it using this. So it will run a loop from counter -1, that is the last value, up to the 0th value, and it will print it, and it will store it in the string variable called rev. So I have here defined rev as null, so that the value will be stored in the rev. Now here it's asking enter the key for shared memory. Same key we have to enter. Then using shmget, it will get the value, and then you have to give the key name, then the size, then its permissions. Now if the ID is less than 0, the shared memory will not be created, and if it is not 0, then the shared memory is created. Then here I have virtual address. Then the same thing I'll do using shm at. So this will point to the ID that we are having. So the shared memory ID, it will search and it will point this pointer. Then the pointer's address will be copied to str. Then it will say received string. So whatever we have received from the shared memory, I will call string reverse function here. The string will be reversed. The string will be passed to this reverse function, and the reverse will be stored in rev. So rev, since rev is string, it will be converted into a character array here that we have here now, and then that part will be copied to the string, and then string will be printed here. So this part will just modify the string in the shared memory. So at the end of this line, the string will be modified in the shared memory. So thank you for watching the video.